Okay, so this is a pretty good video for me to do so that you guys can kind of watch this over again. 5.2 and 5.3 are going to be especially tricky to begin with, but once you figure out how to do it, it will actually be quicker than solving by graphing. So again, in this section, what we're going to do is learn how to solve linear systems by using substitution. When you think back to the basic things of substitution, we've had problems in the past where we see things like x plus 2y equals 10, and you would substitute in a value for x, we'll just say 4, and a value for y, let's say negative 3. But we should know how to substitute. We would say 4 plus 2 times negative 3, and we would see if that would be equal to 10. So what we're going to end up doing in this section is taking whole equations and subbing them in for variables rather than just a number. We're going to take an equation and substitute it in. So in this section, we have the core concept box. Again, these are always valuable things, so if you want to add this to your notes, it's basically a way that describes how we solve the problem step by step. So step 1 is solve one of the equations for one of the variables, and notice it doesn't say to solve for y or x specifically. It just says to solve and isolate one of the two variables. Step 2, it says to substitute the expression from step 1 into the other equation and solve for the variable. And then it says substitute the value that you find from step 2 into one of the original two equations that solve. It seems wordy. Really what's going to be beneficial for us is to just see a few examples. So looking at this one, in example 1, you can see that we have a variable that's isolated already. So basically this right here takes care of step 1 for us. Y is isolated. We don't have to go through the trouble of isolating something else. But what we're going to do is we're going to let the fact that we know that y equals that and plug it in for this value y right here. So I'm going to take the bottom function 6x minus 5, and then instead of y, like I said, I'm going to write negative 2x minus 9 for y equals negative 19. Then all I do is solve, because now I only have one variable to get rid of, and it's the x, so I'm going to solve for x. I do that by distributing the 5, so I take the 5 through the parentheses. I get 6x plus 10x plus 45 equals negative 19. I go ahead and combine like terms. I get 16x plus 45 equals negative 19. When I subtract the 45 from both sides, notice they are the same sign, so when we have the same sign, we add them up and keep the sign. I get 16x equals negative 64. I divide by 16, and I get x is equal to negative 4. Now again, keep in mind that when we solve linear systems, our answers are coordinate points. The only thing I found so far is my x value. So what I do to find my y value is substitute that into either of the two functions. What I'm going to say would be easier is to solve it and plug it in for the x in the equation where y is already by itself. So now I'm going to say y equals negative 2 times negative 4 minus 9. Negative 2 times negative 4, I get y equals 8 minus 9. 8 minus 9, y equals negative 1. So I get my solution to the linear system, negative 4 comma negative 1. Because this is something relatively new to us, again, you can try this on your own if you want, but I will show you another one, and then you'll have some to try on your own here shortly. Again, in this one, you can see that we already have a variable isolated, and it just happened to be y. It won't always be y, and it's better if it's not, because sometimes it's easier for us to kind of change things up. So again, we have the value or the fact that y equals negative x plus 3. we're going to plug it in for that y right there. So again, we're going to write our function 3, and then I'm going to plug in negative x plus 3 in for my variable, and then I'm going to continue to write the function plus 5x equals negative 1. We can solve by distributing, so we take this 3 through the parentheses. Negative 3x plus 9 plus 5x equals negative 1. We combine like terms. 2x plus 9 equals negative 1. We subtract 9 from both sides. 2x equals negative 10. We divide by 2, and we get our value x equals negative 5. Again, negative 5 is just the x value. We need to find the y. So what I'm going to do is plug that in, y equals negative, and I plug in the fact that I know x equals negative 5 in, and then I add 3. So we see this double negative here, so that changes it to a positive 5 plus 3, and it looks like my output is 8. So negative 5 comma 8 is the solution to that system. Once again, you guys, I can't stress enough how important it is for you guys to actually pause and try these on your own. If all you're doing is watching me do them over and over again, you'll never really figure out how to do it on your own. So make sure you give it a shot on these three, or at least one at a time, to make sure you're doing it right, and not just to watch me do it every single time. Number one, it's kind of tricky, and it's not really meant to do anything but make you think. Notice how I have y isolated in both functions. So really all I need to do is set these things equal to each other. If we know y equals negative 4x, I can plug that negative 4x in for y, and then I can just write the rest of the first equation, 3x plus 14. So really on number one, all we're doing is just getting rid of the y. Now we can solve negative 3x. We have to subtract it from both sides. I have negative 7x equals positive 14. We divide by negative 7, and we get x is equal to negative 2. We plug that negative 2 into either function. I'm going to choose the bottom one just because it'll be a little bit quicker. Negative 4 times negative 2, I get my answer, y equals 8. So the solution to number 1 is going to be negative 2 comma 8. And that's the solution to our system. Number 2, we have the fact that we know y is by itself in the second equation. So we can take all of this and plug it in for the y right there. So that's what I'm going to do as I copy this down. 3x plus 2, and then again I'm going to take this and I'm going to plug it in, times 1/2 x minus 1. Sorry, I'm running out of room a little bit here, and then I'm going to say equals 0. I distribute the 2, so I get 3x. 1/2 times 2 is just 1x. 2 times negative 1 is negative 2 equals 0. I combine like terms. 4x minus 2 equals 0. I add the 2. I get 4x is equal to 2. I divide by 4, and I get x is equal to 1/2. Well, 1/2. Okay, so now that I have that, let me erase that and clear that up a little bit. Now that I have the fact that x is equal to 1/2, I just, again, plug that value in for x and find y. So now that I have that, I'm going to say y is equal to 1 over 2 times x is also 1/2 minus 1. 1/2 times 1/2 is 1/4 minus 1. When I do that, I get negative 3/4. So the solution to number 2 is 1/2 comma negative 3 over 4. That one's pretty tricky, but we'll be alright. We'll see how the next one goes with solving x. So what I'm going to do now is go ahead and erase some of this so that we can see to do number 3 in here. Looks like I might have to do it on the next page. I don't know how much of this is going to erase. Here we go. That's weird that only some of it erases like that. Sorry, guys. So as we look at number 3, it's a little bit different. Let me finish erasing here. But number 3 is a little bit different because now y is not the one that's isolated. X is actually the one that's isolated. So when we go to do this one, it's going to look a little bit different. We're going to say, okay, now I'm going to take the fact I know 6y minus 7 is equal to x, and I'm going to plug it in there. So I'm going to say 4 times 6x minus 7, 6y minus 7. I got so used to plugging x in. It's 6y minus 7. And then I finish writing my equation plus y equals negative 3. I distribute the 4, 24y minus 28 plus y equals negative 3. I combine like terms, I get 25y minus 28 equals negative 3. I add 28 to both sides, I get 25y is equal to 25. I divide and I get y is equal to 1. Again, all I need to do is plug it into the equation where x is already isolated. So if we look at that there, I have x equals 6 times 1 minus 7, and it's pretty easy to see that we get x is equal to negative 1. Now it's important to keep in mind that x is negative 1 and y is positive 1. So the solution of this system, negative 1 comma positive 1. And there you have it. There's the answer to number 3. Again, make sure you understood all that along the way there. I know I had to erase some so that there was room on this page. You can always go back and watch it again to make sure you got the right thing. I kind of like the little side note that X has, or that example 2 has here for X. It says you could also begin by solving for X in equation 1, solving for Y in equation 2, or solving for X in equation 2. You can really do anything, you guys, here as far as isolating a variable. What we always look to do is make our lives as easy as possible. Look for a leading coefficient of 1 on any term, and if you can't find a coefficient of 1, like on these y's the coefficient is 1, negative 1 is the next best option. Really anything but isolating this x right there would be pretty easy. So as long as you're not dividing by 3 everywhere and working with a bunch of fractions, it's going to make the problem pretty easy to do. So the first thing we want to do in this problem, like it says, is isolate one of the variables. So we have negative x plus y is equal to 3 for one of the systems, and then I have 3x plus y is equal to negative 1 for the other one. What I'm going to do is I'm going to go ahead and isolate the y in the first equation just because it'll be the easiest to work with. So we add x to both sides. After we add x to both sides, we get y equals x plus 3. Now that I have a variable isolated, I can take that value that I know for y and plug it in for the y right there. So again, we have 3x plus x plus 3 equals negative 1. So again, notice all I did was took that and plugged it in right there. Combine like terms, I get 4x plus 3 equals negative 1. We subtract 3, we get 4x equals negative 4. We divide, we get x is equal to negative 1. Once again, it's easiest to plug it in where we have the variable isolated. So we have y equals negative 1 plus 3. We add those together, we get y is equal to 2. So the solution of this system is negative 1 comma 2. I'm probably going to have to add another page here. We'll see what happens if we run out of room or not. So again, now that we kind of understand this, make sure you try these on your own. But I'm going to get right into it here. So on number 4, I'm going to write the two equations out. X plus y equals negative 2 and negative 3x. That's a line there. Negative 3x plus y equals 6. I'm going to isolate the x in this equation, so let's subtract the y just to see something different. X equals negative y minus 2. Now that I know that I have something isolated, I can plug that in for x right here. So I have negative 3 times negative y minus 2, and I finish writing that equation, plus y equals 6. I distribute, I get 3y plus 6 plus y equals 6. We combine like terms. 4y plus 6 equals 6. We subtract the 6. We get 4y equals 0. And we end up getting y is equal to 0 there. Then we plug in 0 anywhere really, but if I plug in 0 right back up here where I have the x isolated, x would just equal negative 2. So it looks like our solution for number 4 is negative 2 comma 0. Again, we can always check. Let's check up here. Negative 2 plus 0 is negative 2. Negative 3 times negative 2 is 6. Plus 0 is 6. So it looks like that checks out. You can always go back and check if you're unsure. Number 5, we have negative x plus y equals negative 4. And then I have another equation. I'll write it up above a little bit. 4x minus y equals 10. Again, always isolate a leading coefficient of 1 if possible. The only one that has a coefficient of 1 is this y right here. So I'm going to add the x to the other side. So I get y equals x minus 4. Again, we take this value x minus 4 and we plug it in for y. So I'm going to say 4x minus, and then I say x minus 4. And then I say equals 10. Now, since there's a minus sign in front of this y, we really have to distribute a negative 1 here to solve. So when I do that, it's going to say 4x minus x plus 4 equals 10. We get 3x plus 4 equals 10. 3x equals 6. And x is equal to 2. Again, we go ahead and we can plug 2 in right there, so we can say 2 minus 4 is negative 2, so we should get 2 comma negative 2 for our solution on number 5. So again, like I said, I'll have to add another page here. Give me just a moment. Okay, so again, when possible, isolate something with a leading coefficient of 1, but we don't have that, so we'll have to make do with the negative 1. 3x minus y equals 1. And let's isolate the variable in this top one. So I'm going to subtract the 2x from both sides. When I do that, I'll write what I have here. Negative y equals negative 2x minus 5. I would divide everything by negative 1 because I want to solve for y, not negative y. And I get y equals 2x plus 5. So now that I have that variable isolated, I'm going to take that and plug it in for y. Again, we have the same thing going on with that negative sign. We have 3x minus, and we'll put that in parentheses so we know to distribute 2x plus 5. The only reason we don't have to distribute when it's a positive sign is because it wouldn't change any values normally. Otherwise we would have to distribute. So this negative sign changes those values inside the parentheses to negatives instead of positives. It just flips the sign. 3 minus 2, we get x minus 5 equals 1. We add 5, we get x equals 6. We go back and we plug in 6 up in the equation where we had y isolated, and I have 2 times 6 plus 5, so 2 times 6 is 12, plus 5 we get y equals 17. So the solution should be 6 comma 17. Okay, next one, number 7. Looks like x is going to be the easiest one to isolate in the first equation. So I'm going to go ahead and add the 2y to both sides. So we have x equals 2y plus 7. we take the 2y plus 7 and we plug it in for the x. So I'm going to say 3 times 2y plus 7, and I'm going to say minus 2y equals 3. Once I'm finished with that, I distribute, so I get 6y plus 21 minus 2y equals 3. Combine like terms, 4y plus 21 equals 3. We subtract the 21 over, we get 4y equals negative 18. We divide by 4, and it looks like we're going to get a fraction here, which is not the end of the world, so we'll go ahead and do that. It looks like this 18 over 4 will reduce to, let's see what goes into both, 2, so I say negative 9 over 2 for x. Then again, we can just plug in negative 9 over 2 for the y value, excuse me, for y, not for x. That was y. I had it all the way till the very end. So we have y equals negative 9 over 2, and we can plug in that value for y, clear back up here where x is isolated. If I say negative 9 over 2 times 2, that's just negative 9 plus 7 is going to be negative 2. So y is equal to negative 2. So the solution to that system is negative 9 over 2, comma negative 2. So again, you can see that we from time to time will get fractions for our coordinate points. That's just going to happen when we find that where they cross, there's going to be fractions and decimals and things like that from time to time. Sorry guys, I just realized I made a mistake that I'm going to have to watch for you guys to do too. Notice here I have negative 9 over 2 here, and I even had to correct myself. Sorry about this, guys. But y is negative 9 over 2, so these points should be flip-flopped. This is x, not y. So our solution should be for this negative 2, comma, negative 9 over 2. We'll have to watch for things like that. So again, ignore this. Our solution is this right here. We'll have to watch for mistakes like that and see if we can't correct our own mistakes as well. So I'm glad I caught that before I uploaded it, but again, I wanted to go ahead and draw that to your attention here. The last little thing, you guys, here is a good example of it being a shorter process to solve by eliminating or substitution rather than graphing. So again, it's just a linear system and you're trying to find where these two things intersect. It's kind of set up for you here. This would certainly be a way that I would recommend doing this problem on a test. I would not say we should graph this because, again, with your slope and y-intercept being such big numbers, it's really pretty impossible to graph. So solving this one by using substitution would go pretty easily. You would just take 2y and plug it in for this x, and then solve for y, then go back and plug it in for x like we did on the rest of it. You can take some time and do that and then look it over in the book, but I just wanted to give you guys an opportunity to kind of go ahead if you wanted to.